Hello and welcome to today's webinar, ZIP Economizer, the easy path to code-compliant economizing. Today's presenter is Justin Lindstrom, and in just a few moments he will join us on the line. But before we get started, I'd like to go over some housekeeping rules in order to make this webinar enjoyable for everybody. So this webinar will be recorded and posted to a Belimo website at a later date, so that if you need to step away or want someone else to view this webinar in its entirety, we can send you the link in which you can view the webinar recording at a later time. We run our webinars as such. We have a 20 to 25 minute presentation worth of content and then about a 5 to 10 minute question and answer session. If at any time you should have a question, you can open the question box, type in your question, and I will get to them at a later time. If you have any technical issues, please type in your issues using the chat feature, and I will be able to assist you as best as possible. So without further ado, I'd like to introduce you to Justin.
Welcome. My name is Justin Lindstrom. I'm the product manager here at Belimo for the ZIP Economizer and air performance devices. Today's webinar focuses on the recent changes made in the energy standards and codes respective to airside economizing. First, we're going to discuss recent changes made to all the energy codes and standards applicable to economizing. Then we'll get into a quick overview of the ZIP Economizer and some of its functionality. Next, we'll walk through how easy it is to set up the ZIP and review some additional facets of its operation. And we'll wrap up with some retrofit offering and open the floor to some questions. Let's get started. This slide here represents the current state of the energy code adoption by the individual states. Side note, as of 2014, any federal building must comply with the current iteration of ASHRAE 90.1. Blue states have already adopted the economizer requirement for AHUs 54,000 BTUs and larger. Additionally, these states are required to have an integrated cooling mode of operation. What is integrated cooling? Integrated cooling is when economizing conditions are present where temperature and enthalpy are below the high limits, and the first call, Y1, uses an outdoor air to satiate the cooling demand. If the load is not satisfied with 100% outdoor air, the thermostat will call for a second stage, and the economizer will begin to engage a compressor. States in green are mandated to have economizer, fault detection, and diagnostics in addition to the blue states. California has developed and implemented its own energy code standard, with most mandates meeting or exceeding both ASHRAE 90.1 and IECC 2015. Well done, California. So let's dig into the fascinating world of regulatory code. What's new in ASHRAE 90.1 2016? A major addition to 90.1 standard is the incorporation of fault detection and diagnostics for economizer controls. Be warned, the content is going to get a little dense for a few minutes, but seeing as all three of the code bodies have made amendments regarding this requirement, I believe it's worth digging into. It really won't take too long. Fault detection and diagnostics, or FDD, encompasses the economizer's ability to monitor its input, processes, and outputs in order to determine if there's an operational fault. ASHRAE 90.1 FDD system requirements are as follows. Although the language differs between IECC and Title 24, the following requirements are shared. Temperature sensors shall be permanently installed to monitor system operation. These include outdoor air, supply air, and return air when required for economizer operation. The system shall have the capability of displaying each value of the sensor connected. The FDD system shall be capable of and configured to provide system status by indicating the following: free cooling when available, economizer enabled, when the compressor is enabled, when heating is enabled, and when mixed air low limit cycle is active. The FDD system shall have provisions to manually initiate each operating mode, so the operation of compressors, economizers, fans, and heating system can be independently tested and verified. The FDD system shall be capable of and configured to detect the following faults: air temperature sensor fault, not economizing when the unit should be economizing, economizing when the unit should not be economizing, damper not modulating, and excess outdoor air. The FDD system shall be capable of and configured to report faults to a fault management system or application, like a DDC or a BMS. Or it actually could be enunciated locally at a thermostat serving space. That's the extent of the code speak. Thank you for sticking with it. The second update in 90.1 is the replacement of a portion of existing buildings. This new mandate states that the equipment must comply with these new standards set forth. This encompasses systems like economizers and fan speed control, which were previously limited to new installations only. What's new in IECC 2015? Here we go. Fault detection and diagnostics. Units with cooling capacity greater or equal to 75,000 BTU shall have no fewer than 2 stages of mechanical cooling. Stage cooling requirements. Units with airside economizers have no fewer than 2 speeds of fan control while economizing. California Title 24 now mandates that units with cooling capacity greater than 54,000 BTUs now include economizer control that support enhanced fault detection and diagnostics. Let's have a brief overview of the ZIP's operation. In addition to being up to date with the latest regulations, the ZIP leverages the power of the ZIP code for easy setup and configuration. It also provides plug-and-play connectivity for sensors and attached devices. Alarm history is available with the last 10 alarms stored internally with a timestamp. Ease of use onboard guidance for when questions arise during installation, and the ability to perform functional testing for commissioning and troubleshooting. The ZIP also provides some extended functionality. Integrated cooling, where the first stage of cooling will not activate until the outdoor damper is at 100%. CO2 demand control ventilation, which allows you to lower the minimum ventilation outdoor damper position based on CO2 concentration levels in the space. The accuracy of the ZIP sensors are within code specifications. The ZIP includes some additional compressor protection strategies designed to provide additional energy savings: 2 feet span control, the ability to purge the building before occupancy, a manual mode for operational checkout, fault detection and diagnostics, brownout and freeze protection strategies, and an exhaust fan output for pressure relief. So how easy is to be code compliant? It's as simple as entering the job site zip code. Here we have Binghamton, New York, zip code 13748. Enter the zip code, and depending on the sensor array connected, the economizing strategy is selected, in this case, fixed dry bulb, and the high limit changeover temperature of 70 degrees Fahrenheit is determined by the climate zone 5A requirement. Here we have Huntington Beach, California, zip code 92649. Enter the zip code, and again, depending on the sensor array, the economizing strategy is selected. Here we have differential dry bulb, and the high limit temperature differential is determined by the CEC Climate Zone 6 requirements. Now we'll touch upon the setup and operation of the ZIP. So what's required to get the ZIP up and running? the job site zip code, and minimum ventilation position. Until these are entered, setup incomplete will display. Listed on the slide are the minimum hardware requirements. To get the zip operational, you must have an outside temperature sensor, a supply air temperature sensor, one compressor stage, a thermostat capable of 2 stages of cooling, and a damper actuator with a 2 to 10 volt input and feedback output. This slide is a graphical depiction of those requirements. So we have a unit. There's an economizer assembly, a spring return fail-safe actuator, zip base control, the energy module, a supply air temp sensor, an outdoor air temp sensor. And finally, a 2-stage thermostat. We get a lot of calls on this particular requirement. You can use a 1-stage thermostat, but you lose the code compliant functionality. You will no longer get free cooling, and you only get integrated cooling. So don't use a 1-stage thermostat. ZIP is also capable of working with heat pump units. It can be configured to work with O, B, or W1 defrost controls for it. It's worth noting that at any point in the setup process, if you come across a setting you'd like some more information on, anytime you see the I button on the display, it denotes that further information is available. In this case, DCV, or demand control ventilation, the CO2 threshold, has additional text to describe what the parameter is. We also have some optional equipment for the ZIP. This is the energy module, or Econ-ZIP-EM. The energy module allows for extended functionality, including exhaust fan control for pressure relief, demand control ventilation, which we just touched upon, remote damper override. This is useful in situations where you like to manually open and close the outside damper. Some examples where this would be useful is if there was a chemical spill in the space and you like to purge the space, or we have some customers in California who close the damper when there are some wildfires upwind to mitigate smoke. And 2-speed retrofit fan control, as well as pre-occupancy purge. Here's the communications model, or econ-zip-com. This allows the hookup of a remote or diagnostic alarm. So if any one of those FDD requirements are like a sensor fault, you can hook up this to a BMS or a locally attached LED, and it'll indicate that alarm is present. It also is the point for attachment for BACnet MSTP over RS-45. So once all the parameters are set, you'll go into damper scaling mode. It will perform a countdown before it goes into operate in automatic mode. The intent of this is to determine the mechanical limits of the damper assembly and rescale the actuator output to represent the controlled position of the damper. It's important to note that a visual inspection must be completed prior to setup. Belimo also offers a host of retrofit kits. We call these the ZIP packs. And the kit includes the ZIP Economizer base, the energy module, a supplier temp sensor, choice of modulating spring return actuator depending on the size of your damper, mounting brackets, shafts, and accessories, and a choice of outside air and interior sensors depending on the desired high limit changeover strategy. Here's a quick look at some job site retrofits. On the left is a micro metal economizer assembly that has been retrofitted into an existing train unit. In the middle is a Cambridge port assembly retrofitted into a carrier unit. And on the right is an old Honeywell linkage that was repurposed with a ZIP retrofit kit. You do not have to retire an old unit to gain efficiency. This slide illustrates how easy it is to replace these antiquated economizer controllers on the left with advanced Belimo code-compliant technology on the right. Thank you for participating in today's webinar. We appreciate you taking the time out of your day to invest learning more about Belimo's offerings. If you'd like to continue this conversation, please feel free to email me at this following address.
All right, thank you so much, Justin. We all learned so much from this webinar. Now we've reached the portion of this webinar where we will have a question and answer session. So if you do have any question, what you can do is open up your question box, type in those questions, and I will read them aloud, and Justin will answer them as best as possible. If at some point we should run over and we don't get to your question, I can assure you that Justin himself will reach out to you and get those questions answered. So are you ready, Justin?
Yes.
Okay, first question. Is the ZIP compliant with Canadian codes?
It is, and I am remiss for not putting a slide in for our neighbors to the north. ZIP is compliant with NECB 2015.
Okay, thank you. The next question, I've heard through my distributor that BACnet will soon be available for the ZIP. What is the timing on this?
BACnet. Right now, we just finished internal testing, and we are now turning over the product to the BACnet Testing Lab, or BTL, for their certification. I have to go through a bunch of tests to make sure that the ZIP is going to play nice with others on a MSTP communications trunk. So timing for that looks to be first quarter 2018 till we release it to market.
Okay. Going to do a last call for questions. So again, if you have any questions, you can open up your question box, type in the question, and I will read them aloud. I want to thank everyone for joining us today for this webinar. Thank you, Justin, so much for this excellent topic. Doesn't look like we have any additional questions. Once again, thank you for participating, and we look forward to having you participate in our next webinar, which is going to be on the 18th of October, and that's going to be a fire and smoke webinar. Thank you so much, everyone, and have a great day.